Hello, good day to everyone. I welcome you to another episode on Moldflow's workflow and tips. I hope these episodes are helping you to improve your productivity and also learning some tips and get the cheat for the to get the best out of the software. In today's episode, I'm going to discuss on to the optimizing the mesh densities or the mesh elements we call it. Often I've been hearing about that, we've been using or some of the users been using external third-party solutions for generating the surface mesh. No, nothing harm in it. But let me tell you that Moldflow mesh algorithm has gone a significant change since the version 2016 onwards. That could be changes into the automation of the mesh. Instead of specifying the local edge length, now algorithm automatically assigns the mesh density or the edge length based upon the feature. Well, there are the options to change or overrule that automated mesh algorithm and specify the global edge length as we were doing it in legacy, as well as the chord edge length as well. So let's try to see workflow on a simple model and later do a comparison. And during the workflow, I'm also going to show you how do you go and assign the mesh densities at the critical features which are difficult to get captured using the automated algorithm. So with that, I'm going to import a simple lamp holder sample model that I have it, and I'm going to demonstrate using a dual domain mesh. Well, dual domain mesh always lies an base for the 3D mesh. Well, there is an option to directly import the CAD model and run the simulation. So algorithm automatically converts that surface into the 3D mesh, but again in the background it converts the CAD model into the surface mesh and then gets into the 3D layer mesh. We'll also see some of the options while importing. Well, you can see that there is an option for directly importing using a Moldflow design link. I highly recommend using this and always use a native CAD model, whether you are using any of the major CAD platforms, and all of the CAD platform native models can be imported, so no plugin needed, everything is been inbuilt on it. Well, there is an option to convert these solid models to the surface mesh as well, particularly if you want to play around the mesh on the surface and so on and so forth. You can translate those solid models into the surface data. For the demonstration purpose, and I'm going to use a solid model. Again, the option of layer name based on the CAD model. If you are using directly a native CAD model, whatever the names that you are given it to the different components, particularly assembly, it gets imported as that one. So with that, let's begin it. I'm importing as a dual domain model, and as it gets imported, then I can get a symbol of like blue over here or a magenta color that symbolizes or says that I'm going to use an dual domain mesh, as well as same thing I can see over here. It's like a wrap mesh or a surface mesh that's going to be created out of it. So best option is I always prefer using a generate mesh, and when I click on a generation mesh, it says that mesh match as well as calculate the thickness for the dual domain mesh. And if you are putting a gate location somewhere else, you can apply the refinement near the gate area. And this is highly recommended for the 3D mesh. Before you go for the 3D mesh, to capture the shear heating and the temperature rise because of the shear heating. So I will highly recommend having a refinement near the gate area. And then when you click on the most of the users, they just look at the general and they think that the global edge length would be used, but you can clearly see over here that the global edge length used when the local edge length is not defined on the geometry. And then there is an also option that when you're clicking on auto sizing, what does it means that it automatically defines the mesh needed for the small features or the thing. So something like an biasing type of mesh will be automatically created, and this will go with a factor of 1. Whatever that mesh global edge length will be, it will be 1, whatever been calculated by the algorithm, so it goes with the default. There's an option of the local parameters. When you click on use global parameters, whatever the global edge length specified over here would be used, else it will be just be a use auto sizing. So be careful on this. By mistake, if you are doing the mesh, be sure that you are using a auto sizing because it's more appropriate. Let's go, and then you can also have a preview of like how the mesh would look like and see the elements that get created on it, whether the features are getting captured or not. And for the time being, I already created the mesh using a default mesh sizing, and let's see how the mesh looks like. Pretty much it has created a nice mesh, and of course the feature that is onto the back side is also getting imprinted over here. So I'm going to get a sing mark or the impression of the sing mark nicely if you have these mesh match ratio or the matching of the elements from the feature on the other side. The important thing to look at is how the mesh statistics look like, the quality criteria. And you can see that it has created around like 55,000 elements plus 55,000 plus elements, and the mesh match ratio percentage for the dual domain mesh well should be about 90 for any warp analysis, and in this case it's like 93.6, and it looks to be a good mesh, fine. But I want a little bit a finer mesh in these areas, particularly these features, and looks to be, yeah, that's fine, but can I improve upon it? So let's go, and in second case what I'm going to do is when I click on a generate mesh in the CAD, default is 1, so I'm going to put as a 0.8 and going to mesh it. For this also I have already created the mesh to save the time. And how does it look like? Now whatever the global edge length or the automated mesh edge length that is going to be specified by the algorithm, that would get multiplied by 0.8, so it's going to reduce the overall mesh length. Of course the mesh density number of elements are going to increase, but now I could see that there is better capture of these features around those circular or the finer features. Much detail has been captured around it, and of course the element has from 55,700 it has ramped up to 84,400 elements. Let's look at the mesh density or the mesh statistics for it, and I'm particularly interested. Yes, so there is an increase into the mesh match percentage also, as well as the reciprocal percentage as well. From 93 it has gone to 94, 1% increment in it, but at what cost is like almost like 20% or 20 more than that. It has increased the element numbers or year. So be cautious when you using these auto sizing as well, and when to use. So if your model is having a lot of fine features and you want to capture it, well, you can use it. So other trick that I always recommend using is that the combination of the global edge length and the mesh densities. Now I've been using a mesh densities a lot when the automatic algorithm was not there in the year like 2010 and so. So how does this algorithm or the local mesh density works? So click on your model, and in the selection particularly, geometry selection, you can see that I have been selecting completely a CAD body. And then if you go into the select on surface, I can select the surfaces, and that is another way is I can also select the edges as well, all the curves. So I'm going to select a complete model, then say define the mesh density, and you can see on the left hand side of the screen, you'll get all the faces gets highlighted. Now when these faces are getting highlighted, if I click on the F1, it selects the face, and below that it has the edges that forms that face. So if just select these edges will not work. If you keep a control button and if you're selecting all these edges, it will just select those edges. But if you want to select the faces, then you have to click on the face as well. So in this case, I'm selecting the edges and the surface. So which is the appropriate way? Well, you can define the mesh density, local mesh density to the edges as well as to the surface. Now you would be saying it becomes very cumbersome. How can I go and select those particular? Can I have to look at those faces or edges in the tree? Not really. So I'm going to select my selections from this geometry tab into the selection from the body to the faces, and in this case I'm going to select the control button, and then I'm just going to select the needed faces for it that is needed. Or you can always use the facing entities to select the faces. And you can see that I selected this, as well as on the back side also I'm going to select these faces. So I selected the faces around it, as well as the edges also for some of this the feature or the face. And I'm going to do it for all those small details that I have it on my model, so that it gets captured precisely. And then I'm going to create a group out of it. I'll show you how to create the group as well. So if unnecessary elements are getting created, you have to hold on the shift button and then click it. It will get deselected, and then you can, or the control button will also work. Control and left mouse button, it will work for the selection purpose. So in this case, I'm going to create, for the time being I'm just selecting this, but I would have selected all of these small holes and those features, these features like this I would have selected, and now I'm adding over here, and I'm going to give as a small feature name. Small features, and you can see there is an option to now apply a local densities to it. So in this case, I'm going to apply 1.2, and the global edge length would be like 3.2 allow. So, and I'm going to say apply it, hit OK. One more thing I forgot to show it to you is when you click on the mesh densities. So for the complete, let me select the complete model and say mesh densities. What it does into the sort by, it sorts by the face ID, and then it goes from smaller area to the large area. If you want to have look at the smaller area in your model, you can just go and click on those smaller areas. Those gets highlighted immediately on this. Okay, so you can try working, or it is from larger to small as well. In that way also you can do the sorting. For the time, to reduce the time, again I have run a mesh with the mesh densities now, and let's see how does it looks like. So you can see that I have a very fine mesh around those features which are of interest to me, and rest of the part is having a mesh density of 3.12, and only for the selected features, which are these, are having a mesh density of 1.25. And I could get a triangle. Number of triangles is like 67,000, quite between like a 0.8 versus the one that global having. And let's look at the mesh statistic. How does it looks like? Well, the match percentage has not changed. It remains the same as that of the global edge length or the default mesh. Of course, the reciprocal little bit has improved on that part. Rest of the things pretty much. Of course, the number of elements has increased almost by more than like 10% or so. And yeah, so this is like a combination of the now defining a local mesh density versus the automated mesh. Now, one more thing that we can do is assigning a chord height. So when you are selecting the local mesh density, there is an option. When you are using a global parameter, there is an option of the chord angle as well. Now, what this chord angle is all about is how many number of elements do you need to have if it is a small features or so. Let me explain it very quickly. So if suppose I want to have let's say I'll just mark it here. I'll divide it like this. And if you see the delta angle here, in this case, is of 90 degree, this angle. So if I have a chord angle of 90, it will create like an only, put it, one node here and other node here in the circle. But if I reduce this, say suppose this guy, if I reduce this to say suppose instead of 90 I made it 60, now this is 60, the another node will be created over here now. And like this, it gets divided. So you'll get a more number of nodes along the circular feature, and it will get more precisely captured. Smaller the chord angle, more the number of elements you will get it around those circular features. So let's see how does this works. I have put the chord angle of 60 and I ran it. And how does the mesh look like in this case? Well, the mesh, as you can see now, it has captured these very precisely. You can see a lot of elements has been created along those curvature features and so on and so forth, as well as these circular holes and those round edges has been captured very precisely, and more than number of curves in your model, it will create a more fine mesh around it. So it is highly recommended that you remove the radius, unwanted radius, before you go and opt for the chord angle. Let's look at the mesh density in this case is, let's look at the mesh statistics in this case is, and it looks out to be 90. It has reduced because it could not able to match the number of elements that has been created from on this side and this side. So it definitely will reduce the mesh match on this. But on the other side, it has increased the number of elements as well. So I would recommend using the chord angle unless and until there is small details that needs to be captured and you are completely get rid of the model with the small radius and this. Else if you try to use it for the model with a lot of radius and curves in it, it's just going to create a lot of elements without that significantly bump up onto the mesh match and reciprocal percentage. And further it will enhance it for the 3D mesh as well. So in last summarizing it, I did a comparison between a default mesh size. You can see that now in a single slide probably, a single slide in, probably you can able to see that now mesh match, default mesh with an auto sizing. I'm getting a percentage of like 93% with an triangle of 55 versus the auto sizing to 0.8. I'm getting like an increase in the number of triangles significantly with 1%, not 1%, also like an 0.5% increment in my match percentage. And then I use a little bit of combination of global edge length and mesh densities particularly, that gives a very optimal one. I'm able to capture those smaller details very precisely, as well as I could able to maintain the mesh percentage as well. And then I go on with an chord height option, or the chord angle option, I would say, and that gave me a lot of elements but no further significant increment into it. So I hope these tips would be helpful in getting a right mesh needed for your model, because this lies a base for the 3D model, and then you can build up the 3D mesh, because it's just going to add the further number of elements and less. Thank you for your time, and hope this tip will help you to improve your productivity. Talk to you soon again. Bye.